Section 13.5, applying the law of sines. All right, this is going to be long, not because it's hard, just because there's a lot of it. So here we go. The law of sines simply says that the ratio of the side to the sine of its opposite angle, they're all proportional. All right, so that's what all of this means. And because they're proportional, you can either put the length of the sides on top or the sine of the angles on top. It doesn't matter. So that's what all of this means. Let's do some quick. So what we want to do is we want to be able to solve a triangle. We want to find all the parts and pieces, the sides and the angles. Now, one thing that I don't know, you've probably figured it out, but I didn't actually say, the capital letters stand for the angles. The lowercase letters stand for the sides, and they match up with the adjacent angles. So capital A, the angle, is across from lowercase a, the side, and so forth. All right? And then, so what is happening here is we can use this law of sines when we have angle, angle, side, or angle, side, angle, and we're going to discover one other type. But if you have two angles, you can for sure use the law of sines. The way you do it is this. First, you know you can find the third angle by simply taking 180 degrees and subtract the two angles that you know. And if you do that, in this case, angle B is 19 degrees. Booyah, one done. So all you need are these two parts. Now is when you can use, well, now you have an angle across from a side that you know. And so the unknowns are the sides. So I'm going to put the side on top just because it's easier to solve, not because you have to do it that way. But I'm going to put the 25 over the angle 19. Oh, actually, I'm sorry, not the angle, the sine of 19. And then choose either of the other sides. So let's do, that's going to equal A over the sine of 94. And then you'll do the little cross multiply thingy to get to, you're going to multiply by the sine of 94 to get rid of this so that A is by itself. And so what you'll do is just plug into your calculator sine of 94 times 25 divided by sine of 19. And that will give you A, which should be approximately equal to 76.6. Okay, so you just set up a proportion with the sides and the opposite angles, the sine of the opposite angles. Set those up, and then you can solve for that. Now, from this point, you can either set up another proportion, or you can use Pythagorean theorem and say a squared plus b squared equals c squared. Make sure that your, oh, you know what? No, you can't. I take that back. That's the whole point of this. This is not a 90-degree angle, so therefore you don't have a hypotenuse, so you don't have an A, B, and C, all right? So you must use the proportions. I was going to do it that way anyway, just to give you more practice using it. But what you're going to do is, now you're going to set up still the 25 over sine of 19, and that's going to equal the side C over the angle that is opposite it, so 67 degrees, so sine of 67 degrees. Multiply by the sine of 67 degrees on both sides. And these cancel out. And so when you take sine of 67 times 25 divided by sine of 19, make sure you've got the signs in there and not just, and make sure these are degrees, so make sure your calculator is in degree measurements. That's going to matter. All right? And you should get, in this case, you should get 70.7. And yes, that makes sense. I was making sure side C is going to be shorter than, yes, okay. I was making sure that was reasonable. All right. Easy enough? All right. So that works quickly and easily if you have two angles. Now, if you don't have two angles, if you have just one angle, if you have two sides and an angle, now if you have an angle, if you just have one angle and it's across from a side, then that's easy. But if you have two sides and one angle, there's lots of different possibilities. All right, so here we go. This chart is on page 883. Also, if you'd like to look at the chart in the book. And sometimes I change it, but this time I pretty much copied it almost exactly the way it's in the book. So your options are this. If you've got two sides and an angle, the angle is not in between those two sides, then you've got a couple of different possibilities. If you've got that angle, so this is angle A, it's across from side A. If A is obtuse, if your angle is obtuse, there's only two possibilities. Either that side A is shorter than side B. If side A is shorter than side B, there is no way for this side A to reach this third side, so you don't have a triangle. There is no triangle. All right? So if side B, if side A is longer than side B, then you do have one triangle and you can figure it from there. All right? If the angle A is acute, there's lots of different possibilities. One possibility is that, so you've got your angle, and you know the angle, so it has to be this, but what we don't know this side, and we don't know this angle, right? So if you've got this side B, and this angle is acute, if this side A that you know, that you've been told, if that side is shorter than the height of this triangle from the bottom to the vertex at the top, then there is no triangle. There's no way for this side to reach the base. The way you find the height is to take the side that you know, so the adjacent side to that angle, the side that you know times sine of the angle that you know. Okay? All right. So, all right. Sorry, I'm getting distracted because you can't use the law of sines if the angle is between the two sides, because you won't know the side across from the angle, and that's important for the law of sines because you've got to set up a proportion. Okay. Sorry, that's an extra. Little rabbit there. Okay. So once you figure the height, if you've got an acute angle, you need to know that height. So once you know that height, you compare it to the side that you know. If the side you know is shorter than the height, you're done. There is no triangle. If the side that you know is equal to the height, then you've got one triangle, and that is your side. That is the length of your side, and you're done. All right. Then you go on using the law of sines to figure out that last side. If you've got an acute angle, and the side that you know is longer than the height, but shorter than side B. If it's shorter than side B, but it's longer than the height, then this can either bump this way or it can bump this way in order to meet this bottom side. So you have two possibilities, two triangle possibilities. And if side A is longer than side B, if side A is longer than side B, you don't even have to figure the height because there's only one triangle. It's going to have to go to the outside and make one triangle. All right, let's do some and see some of the options. All right, so first we've got a triangle, and I'm giving you that angle. The angle that we know is 127, and the two sides are 63 and 42. So the first thing to do is is begin a triangle here. Oh, wait a minute. We can't begin that triangle because 127 is obtuse, right? Okay, so we've got an obtuse angle, and we know that this is angle A. So this is going to be side A. So this side B is 42, and side A is 63. So if side A is 63, that's longer than the 42, so it can reach down to this side. So we do have a possibility. So this side A is 63. So now we can solve this triangle because we have one side, and we have an angle that's across from that side. And so what we've got is let's see, so 63 over angle A equals 42. Oh, you know what? Let's put the unknowns on top. So sine of A, which is 127 over 63, and that's going to equal the sine of what we don't know, sine of B, over 42, which is what we do know. All right? So do you see how I can flip them just to get the unknown on top to make it easier? Because now I just multiply by 42 instead of having to divide and multiply both. This just keeps it simpler. So cross that out. 42 times the sine of 127 divided by 63. And then, oh, you know what? And then what we've got is, now we've got to do inverse sine. Let's see if I did that on my notes. So I didn't. I did it on these notes, I think. Okay. So then when we multiply all of that out, we get, oh, what do we have here? So the sine of b should equal, is it 0.53? Yeah. The sine of b equals 0.53. So to figure out, well, that's fine, but what is b? So then you have to do the inverse. The inverse sine of 53, that equals 32.2. All right. So then when you're figuring all your parts, you're going to list out big A, big A, big A, big B, big C, little a, little b, little c. So big B equals 32.2. And then to figure C, you're just going to take 180 and subtract both of these. So your C is going to equal 20.8. And you'll get that by 180 minus 127 minus 32.2. All right, so we've got our three angles and we've got two of our sides. So to figure your third side, you're going to again use the law of sines. Choose any of the ones you've got. Let's do this one. And now we're looking for a side, so we're going to put the sides on top. 63 over sine of 127 is going to equal, what did we say this one was? That's what we want. Duh. This is A, this is B, this is C. Sometimes it helps to write in the, there we go. Okay. So side C, and we know that C, so we want sine of 20.8. So do you see how it's cumbersome? It's not hard, it's just tedious because you've got all the different parts and all the different places. So make sure that you're just setting up proportions. So make sure that you set up with this one, we've got this side over this angle, and with this one, this is the side that we don't know, and we want to put it over the sine of this angle, which is what we just found out here. So then we're going to multiply by sine of 20.8, multiply by sine of 20.8, then C should equal roughly 28. So you should end up with all 6 parts. 1, 2, 3, 4, 5, 6. All right? Whew, let's keep going. Quick, quick, quick. All right, so if I have the angle 52, now I have an acute angle. So there's lots of different possibilities. So the first thing we check to see is, we look to see is if A is longer than B, then we don't even have to figure out our height. So B is the angle we know. So let's draw our little picture. So B is what we know. Oh, B. B is what we know. That's 52. And it's less, so it's an acute. And A is 6.5 and B is 4.7. Okay, so B is 4.7 and that's across from here. And so this is shorter than the 6.5. So we don't have it quick and easy, but it's not so hard. Now we have to figure out, okay, which of these scenarios does it fit? Is it going to be able to touch this bottom side? So we have to figure out the height. So the height is going to be B sine of A. So actually we're going to have A sine of B because B is what we know. All right, so we're going to have 6.5 times the sine of 52 degrees, and that is roughly 5.1. And so 5.1 is the distance from here to here, and 4.7 is too short. It's not going to go all the way down. Even if we drop it straight down, it's not going to be long enough. So we have no solution here. And we're done. All right. What happens now if I have, what do I have now? A is 62. Angle A is 62 degrees. Side A is 32 and side B is 34. Let's find all the other parts. What do I have? Okay, so now I've got an angle, or I've got an angle of 62. And that's A, so I know B is 34. And this is what I don't, or this is what I know, it's 32. 32 is shorter than 34. So now I have to determine, is it the same as the height, or is it in between, or is it larger than the height, or smaller than the height, or we already know about that. So we know that we need to know what the height is. Let's find it out. Here we go. So the height is going to be B sine of A. So the, I always get confused. B, so the sine, okay, so it's going to be the side not across, so 34 times the sine of the angle. All right, so when you find the height, you're choosing the sine of the angle that you know, and you're choosing the adjacent side. Okay, so 34 sine of 62, and did I do that? Yes, that equals 30. So the height down to here is 30. So 32 is not equal to 30, so we're not going to have just one answer. We're going to have two, because 32 could, let's do it this way. 32 could go down to here, or we could go inward and go to here. And now I didn't show those angles are going to be the same. Okay, so what we're going to do is this. We're going to find one, and then we'll be able to find, we're going to find one of those angles, and then we'll be able to find the other from it. I'll show you what I mean. Here we go. Whoo, whoo, whoo. There's so much, so much. Here we go. We can do this. Okay. So first we take what we know. We know the 62 and the 30, or the angle 62 and the 32 is the side that we know. So we're going to do, and we want an angle. So let's do the sine of A over the side, which is 32. And we know this is 62. Let's put it in there. And that's going to equal the sine of the angle we want to know. So sine of B over the side that we know, 34. Okay? When we do that, multiply by 34, multiply by 34. And now, 34 times sine of 62 divided by 32. Did I do that on my notes? 0.94? I don't know. I'm realizing how very long this lesson is, and I'm thinking that it's covering way too much. We can do this. We can do this. Hang in there. Okay. Where's my notes in here, and see if they make more sense. Sine of 62 over 32. Perfect. So now what did I get? I can't read my own writing. Is it 0.94 or just 90? It's got to be 0.94. So 0.94 equals the sine of that angle. So you've got to do the inverse sine of 0.94, and that's going to equal roughly 69.7 degrees. So B is 69.7 degrees, and we're going to have two options. So either B is 69.7 degrees, and that would be this angle here, right? If we went inward, we're going to have this angle. And if you look, this angle and this angle are going to be supplemental, right? They're going to add up to 180 because this one is the same as this one, because it's just going to swing. It's going to have to swing at the same angle in order to touch. So we're going to take 180 minus the 69.7 to get our other possibility. So that will be 110. Yes, 0.3. All right, so do you see why? That's going to be a supplemental angle. So once you do that, and I think I'm going to leave the rest to you. Once you do that, then you can set up your proportions with both of those. So in order to find, now you know sides A and B. To find side C, you've got to first find angle C. So what you're going to do is you're going to take 180, because that's the three added together, So 180 minus 62 minus 69.7. And that gives you 48.3. Or 180 minus 62 minus 110.3, that will give you 7.7. Okay, so now you have two different possibilities of triangles with these same beginning measurements. So then to find the measurement of C, so if you'll look, C is either this long or it's this long. So there's going to be two different options for C also. So you'll need to use the law of sines twice to find the two different C's. So you're going to have your unknown C. Let's use a different color because this is getting ridiculous. Your unknown C over the sine of C. Excuse me. Your unknown, I'm getting all confused. This is C. Over the sine of C, which is, let's do the first one. And let's go back to our original 32 and A. So then multiply both sides by the sine of 48.3. So 32 times sine of 48.3 divided by the sine of 62 gives you C, which is what? Did I not put those on there? Of course I didn't. Let's see if I put it on here. Oh, I did. 27.1. All right. Then if it's the 7, oh look, that was the longer one. So now if you've got the 7.7, you're going to do the same thing, except what you'll do is this one will be exactly the same. You'll have under here, you'll have the sine of what is the other one? 7.7. And then when you work that out, you should have 4.86. All right? Okay. Here we go. I do have one more thing. One more thing. The area of a triangle. It's going to be so quick, though. Here we go. The area of a triangle is 1/2 times the two sides that you know times the sine of the angle that is not included between, or that is included between them, that is not across from either side. So it's the included, yes, the included angle. So to find the area of a triangle, what you're going to do is you've got, if you know A and you know B and you know C, that's the parts you need. You need a side, you need two sides that are adjacent to the angle that you know. So if you've got a flower garden, two sides, one side is 15 feet and the other is 11, and there's a 62-degree angle in between them. What is the area? You're just going to use the formula. So area is going to equal 1/2 times 11 times 15 times the sine of 62 degrees. And so then when you multiply that out, 1/2 times, so 11 times 15 divided by 2 times the sine of 62, that should be on my notes, and it's not, so let's find these notes. It's going to be 72.8 feet squared. So that's just a matter of understanding the formula. Way easy, and you were very patient. I'm sure you were, right? There's a ton and a lot, but really not very difficult. The hardest part is knowing what to do with those different sides of those different triangles, and when you've got two and when you've got one. All right, you can do this. See you later.